Hi, I'm Victor Medina with TRC Environmental, and I'm here to show you the EVPETS project, which is a joint venture between us, We Think Global, the Army Environmental Research and Development Center. It couples the Enviro system to remove sediments and oils with the PET system, a process which is the PFAS effluent treatment system, a patented reactor system, mobile treatment system for PFAS compounds. We're at Tyndall Air Base, and we're at their firefighting facility, so I'll show you parts of their firefighting operations, their water accumulation and treatment, and then our treatment system and our test. Thank you. This is one of the firefighting training areas, and you can see they have a plane and they can apply hydrocarbons to create fires. You can see the char there. It has right now a oily smell to it. The water is collected beneath the plane through that grate, and we may end up pumping some of this water into the evaporation pond. Now currently we're also discharging our water in here, but this should be a fairly small quantity compared to the water that's actually in this system. This is a jet fuel storage area for the firefighting training. They use this jet fuel to start the fires and provide a realistic training environment. Not all firefighting systems use it. So many now use propane, but here they continue to use the jet fuel because it provides the most realistic training possibilities. This is the evaporation pond, and our pump is in that corner right there. This is another view of the evaporation pond. And our pump, you can see that it gets a lot of foam buildup. The wind blows from left to the right, so the foam tends to accumulate on the left portion of the pond, and you can see that there's a sludge that builds up of really kind of dry foam, as best as we can tell, in the pond. This is a propane evaporation step, which really concentrates down the water. From what I've been told, there's 9 gallons of water. It requires about 1 gallon of propane to evaporate it. So it's a very expensive system, but what I understand, they really don't have very many choices in terms of disposal. So this is what they've had to come up with. This is a propane tank for the evaporation system. This is the Enviro portion of the EVPETS. The water mirror system. It's a chemical treatment system, quite versatile. It's being used right now primarily for coagulation and flocculation, but it could be also used for other kinds of chemical treatments too. It's designed to be portable and flexible in terms of its applications. You can see that there are intake and outtake hoses. This intake hose comes around this way and is taking the water from the evaporation pond, and then the discharge pumps eventually leads into these livets, which feed the PETS portion of the treatment. These are some of the flocculants used in the EVPETS for this project. Hyperfloc. It's a commercially available flocculant used for drinking water. It's a food grade product. So it's inherently a safe material to use in the system. There's also an alum-based material also used in the process, also very commonly used and safe material as well. This compares water from the pond, evaporation pond, which we're currently treating, versus the treated water coming out of the water mirror currently. You can see the one on the left is the water that's coming into the system, and the one to the right is the water that's after the water mirror treatment. This vessel has the brine after treatment with the coagulants. And you can see it separates into 2 phases of kind of still a very dark phase, and then a lighter phase after the treatment that's somewhat transparent. You can see that the dark phase is actually largely a particulate material. The final product is a brine, and this is got the brine right here, a very dark solution. And then with jar testing done on using a coagulant mixture developed by, we think, Global, it's quite a significant difference in cleanup. The Enviro system and the PETS operate at different rates. The Enviro system is about 8 gallons per minute, and the PETS is operating at about 3 gallons per minute. So to account for that difference, we have these blivets so that the flow can be equalized, so that the Enviro system can operate at its preferred rate, and then the water will accumulate, and eventually the PETS will catch up and it will treat the accumulated water. This is the PET system, the PFAS effluent treatment system, a mobile water treatment system designed to treat small accumulations of PFAS contaminated water. It's been previously tested at Hurlburt Field and Sawa Air Base and also Camp Butler in Okinawa, among other places. And right now it's being used as the PFAS treatment process for this study. You can see that the PETS has a nice little control system, very simple to operate. It has its own generator, power. This is the electrical box, and it's also designed so that you can plug in power if that's available. These are the treatment vessels of the PETS. There's one granular activated carbons treatment, followed by several ion exchange resin processes to remove the organic material and then the PFAS. These are the hose reels that provide the water intake and outtake. This one is the intake hose reel, and this is the effluent hose reel. And then it has this pump, hose pump, multi-speed, so you can operate it at different pumping rates. For this test, it's been operated primarily around 3 gallons per minute.